Open the OBJ file downloaded from Polycam. Check the option to map OBJ-Y to Rhino Z to orient the model correctly. The mesh is difficult to see because the color is set to white. Go ahead and change to by layer. The model may need scaling to a larger dimension. Changing the display mode to rendered will display the texture. Go to Settings and update the display mode for rendered so that the lighting method is ambient occlusion to remove the overly heavy shadows. Using the texture map of the mesh will not be very practical. First, the number of texture coordinates is enormous, and second, the texture map is discontinuous, as can be seen with the UV editor command. We can also see this if we extract the texture coordinates in a Python command and translate this to a color. For example, U values to red and V values to blue. We see the patchwork composition here. Instead, we will capture the view and project through it to the object. First, find the viewpoint in which you want to set the object. Save it as a named view and capture to File. If you show camera, Rhino will display the view frustum. If we place the captured image directly on this plane, it will give us an analog to the view that can be directly queried. The viewport boundary can be accessed with a short Python script. This will also export the camera view plane, which will be used later on. This rectangle may need to be scaled up if it appears too small. Bake the rectangle to Rhino and insert the view capture using the picture command. Use 3-point surface to match the non-orthogonal orientation directly. Reference to the canvas with a surface parameter. To keep the focus of this example on the method, I will not insert an object, but will simply place a collection of points floating in space, behind the image plane and within the selected view, and then generate from them a Delaunay mesh oriented to the view camera plane that is perpendicular to the direction of view. Get the mesh vertices with a deconstruct mesh component and draw lines from the camera location to these points. Then intersect these lines with the picture surface. In the first exercise, we had this construction with object attributes and custom map components from human, which extracted the render material and applied coordinates for the texture mapping. In that example, we used UV coordinates derived from a surface closest point component. This will work exactly the same, using the UV output of the intersect component. Don't forget to check that the surface entering the intersection component is reparameterized and that the UV coordinates are flattened.